Hey there, in this video we are going to talk about what is HSRP and then we will talk about HSRP configuration. So let's get started. Well, HSRP is a hot standby router protocol and HSRP is a Cisco proprietary FHRP protocol, whereas FHRP stands for First Hop Redundancy Protocol. To better understand this, let us understand this scenario in which we have network 2.0 and we have network 4.0, and the devices in the network 2.0 wants to communicate with the HTTP server that is in the 2.0 network, and you know that if the devices in a one network wants to communicate with the device in the different network, then they have to use default gateway, right? As HTTP server is in the different network, whereas these devices are in the different network that are because they are in 2.0 network, so must have a default gateway. And you know that in our case we have two routers that are R1 and R3 that are connected to the same network 2.0. So I can choose R1 as default gateway and I can choose R3 as default gateway. So well, but you know that each client just receives only one default gateway and there is no way to use a secondary gateway even if you have one. So here we can just choose one. So let us choose R3 as default gateway, and you can see here that default gateway is the 2.3, right? So let us try to communicate with the HTTP server and access the web page on the HTTP server. So open up the browser and tap the IP address of the HTTP server, that is 192.168.4.5, and you can see that we can communicate with the HTTP server, right? So that's great. Well, but what if this R3 fails? So let us shut down the fast Ethernet 0/0 interface of R3, which is actually acting as the gateway having IP address 2.3. So let us shut down this interface, shut down, and you can see that it has shut down. And let us try again to communicate with the HTTP server and type the IP address again, that is 192.168.4.5. Well, this time you are not able to communicate with the HTTP server, and why? Because the gateway has been shut down. So what should you do? Well, the one way that you can solve this problem is just to manually change the gateway to the 2.1, because R1 is actually up and you can use 2.1 as the default gateway. Now let us change the gateway to 2.1 and to 3 to 1, and we have changed gateway to 2.1. Now let us try again and communicate with the HTTP server. So let us try again and tap the IP address, that is 192.168.4.5, right? So, and this time you will be able to communicate with the HTTP server. So what is the problem with this kind of solution? Well, the first one is that you just lost connection to the HTTP server. In other words, you are just isolated from the outside networks. You won't be able to communicate with the devices in the outside networks. And the second problem is that you have to manually configure the default gateway on each device. For example, if there are so many devices in this 2.0 network, you have to manually go to every device and you have to configure the gateway to 2.1 in our case, and which you don't want. So what should we do then? Well, in case when we have two or more than two routers connected to the same network, for example in our case we have R1 and R3, they are connected to the 2.0 network. So we need a way that in case if one gateway fails, for example if R3 fails, then R1 will take over and it will become the default gateway, and it will be automatic. And moreover, the devices in the network 2.0 will not notice this change, and which means that you will have uninterrupted connection to the HTTP server. And that's what FHRP provides, which is the First Hop Redundancy Protocol. Well, actually HSRP is FHRP, but it's just Cisco proprietary protocol. So what happens in HSRP? And HSRP, multiple routers work together and they act as a virtual router, and basically they present the illusion of a single router to devices in the 2.0 network in our case, and to the devices in the 2.0 network it will looks like they are just connected to a single virtual router. In our case, R1 and R3 are acting as a virtual router, and this virtual router will have virtual IP address and it will have virtual MAC address, and the devices in the 2.0 network will send packets to the virtual IP address of the virtual router, and they will use the MAC address of the virtual router in their frame. Right now R3 is acting as the default gateway, so let us verify this using the traceRT command, and we will communicate with the HTTP server using this. Okay, so you can see here that 2.3 is acting as a gateway right now, and 4.5 is the IP address of the HTTP server. So in HSRP we have active router or forwarding router, and we have standby router. Well, the active router is the one that is routing the packets currently, and the standby router is the one that is waiting, and that will take over when the active router fails. So here R1 is acting as the active router, and R3 is active and as the standby router. So let us configure the HSRP. So first of all, you have to go to CLI. So go to CLI, okay, and then type the enable command, and then const, because what we have to do, we have to go to this interface, that is FA1/0, and we have to configure HSRP. So type interface fast Ethernet 1/0, and in order to configure the HSRP, you have to use the command standby, and then you have to use the group number. And if you don't want, what you do, you can just use the sign, okay, and you will see that there are so many options. So actually it says that the group number can be from 0 to 4095, and I'm going to choose 10 and then IP address. And what will be this IP address? Well, I told you that the virtual router will have a virtual IP address, and this IP address is actually the virtual IP address of that virtual router. And do remember that in this case the host will use the IP address of the virtual router as their default gateway, and I will talk about it later. So first of all, let us configure this, and IP, and I'm going to choose it as 192.168.2.100. all right, and type enter, and then what you have to do, and then we will talk about a priority. So what is priority? Well, do remember that by default the router's priority is 100, okay. For example, R3, its default priority is 100, and the one having the highest priority will become the active router. Or if they have the same priorities, then the router that have the highest IP4 address it will be elected as the active router. So let us as default is 100, so I'm going to choose 105, that is greater than 100, 10 by 10, and the priority is 105, okay, and which means that this R1 will be the active router. Why? Because its priority is 105 and the R3 priority is just 100, and you will see later. Now to verify this, HSRP, what you have to do, you can type the command that is show standby, right, and you will see everything here. Standby. Well, let me maximize it, and you can see it here, that is your state is active, which means that this router is acting as the active router. And also you can see that the priority is 105, okay. So now we will configure HSRP on R3 as well. So you have to repeat the same step, but this time what you have to do, you have to use this interface, that is FA0/0, okay. So let us go to this interface, enable, and then const, and then interface of fast Ethernet 0/0, and repeat the same command, that is standby 10, and IP, that is 192.168.2.100, and this type you don't need to define the priority. To verify this, you can use the command that is standby, show standby, and you can see here that this R3 is acting as a standby, and the priority is 100, which is the default, okay. Moreover, you can also use the command that is show standby brief. So let us use this command, show standby brief, and what it says, it says that the interface is FA1/0 and the group is 10, priority is 105, and state is active, and the standby router interface IP address is 192.168.2.3, and you can see it here. Actually, this is the standby router, and the interface FA0/0 IP address is 2.3. Moreover, the virtual IP is the 2.100, right? Also, as right now the gateway is 2.3, and you have to change it to the IP address of the virtual router. So let us change it, and as the virtual router IP address is 2.100, so you have to change it to 2.100, and you have to change it to 2.100 on this device as well. So let us change it to 2.100, and we have changed the default gateway. So let us try to communicate with the HTTP server again, and let us use this command, that is trace RT, right. So trace RT, that is 192.168.4.5. Well, you can see that the 2.1 is acting as the gateway right now, and just like I told you that R1 is the active router, that's why it's acting as the gateway right now. For the time being, it's acting as the gateway because it's just up. Okay, so what will happen if this this R1 fails? So let us shut down this FA1/0 interface, and you will see what's going to happen. So conf t and interface, there is fast Ethernet 1/0, and let's shut it down. So when you shut it down, what's going to happen? And now let's try again to communicate with the HTTP server using the same HSRP command. So what will happen now? If you type this command, you will see here that this time the gateway is the 2.3, which means that the packets are forwarded to the 2.3. Because why? Because this time this router is acting as the active router, because this router just fails, and this becomes the gateway. And you can verify this using the show standby command. So show standby, and this router is acting as the active router. It's clear, before it was standby router. So, okay, now that we configured the basic HSRP configuration, and so we are going to talk about the scenarios that you might face some problems. So first of all, we will talk about this preemption. What is preemption? So let me unshut down this interface using the no shutdown command. Now that R1 is up, let us type the command show standby again, and this time what you will see is that show standby, and you will see that this router R1 is still in the standby router even if it's up. And why? This is because that as you know that R1 has 105 priority, which is greater than 100. So both routers are up, and which means that R1 must be the active router, but it's still in the standby mode. This is because that new HSRP process has not taken place. So what this standby 10 preempt command do? Well, actually it will force the new HSRP election process, and by doing so, this router having the priority 105, R1 will now become the active router, and R3 will become the standby router again. And let us enable the preemption. So how you can enable it? That is, now first you have to type enable, that is right. Then you have to conf t and then interface fast Ethernet 1/0, and then you have to type this command to enable the preemption, that is standby 10 and preemption, right? So what actually happens here? So it means that if this router fails, R3 will become the active router, but if this R1 becomes active again, that it has the highest priority, it will become the active router again. And that's what actually the preemption do. It will just force the new HSRP election process. To verify it, let us shut down this FA0/1 again. Okay, so const t interface fast Ethernet 1/0 and shut it down, and this time you will see that this router is acting as the active router. Let us verify this as well. It is enabled show, there is standby, and you see that it's acting as the active router. So let us unshut down this interface again using this command. There is no shutdown, and you will see what's going to happen. And let us type this command, it is show standby, and you can see that this router has become active again. And that's what actually the purpose of the standby 10 preempt command. Unlike before, it was just it was in the standby mode, even though it has the highest priority. So let us understand this command, that is a standby track fast Ethernet 0/0. So to understand this, I'm going to shut down this interface, that is FA0/0. So shut down this interface, okay. And now use the HSRP command again. So we are going to use this command HSRP, and you see that the packet is first forwarded to the 2.1 IP address, and then it is forwarded to the 2.3 IP address. So what's going to happen? As you know that 2.1 is the IP address of this interface, which is FA0/1, and 2.3 is the IP address of this interface, which is FA0/0. As you know that when the packet arrives here, as FA0/0 is down, so this packet cannot be routed using this path. So what's going to happen? That's why the packet is forwarded to the tree interface, and we want to get rid of this, because if this happens, mean that if any of the interface of the active router fails, what's going to happen? We want the other router, the standby router, to become active. So in this case, R3 must be the active router, but it's still in the standby router. So what can we do this? So in order to do this, you have to shut down this again, and what we are going to do. So now tab interface fast Ethernet 1/0, and what we are going to do, you have to use this command standby 10 and track and fast Ethernet 0/0. And what's going to happen? Well, actually we are tracking this interface. Now let us verify again, and let us use the traceRT command again, and you will see the difference here. So far everything is normal, right? So for example, the packet is forwarded to the 2.1, and because 2.1 is the active router. So what if this interface gets down? So let us shut down this interface again, that is FA0/0, and you will see the difference, right? So 0/0 and shut it down, and what's going to happen? So use the traceRT command again, and we are going to use it, and that's what's going to happen. And you see that the packet is forwarded to the tree IP address, which is actually the IP address of this interface, which means that R3 has become active router now. And so what happened? So basically what this command do, standby 10 track faster than 0/0, basically decrease the priority of the router by 10. So it means that before the priority of R1 was 105, now it will become 95, and as you know that the default priority is 100 and the default priority of the R3 is 100. So R3 100 priority is greater than 95. That's why R3 is going to be the active router, and rather than forwarding packets to this interface and then this interface, the packets will be forwarded to this interface directly, and R3 will be the active router now. Moreover, these devices will send the frames to the virtual MAC address. To verify, you start this command show, that is standby. You can see here virtual IP address and virtual MAC address, which is AC0A, right? So let us verify it, and if I type this command, that is show MAC address table, show MAC address table, you will see this MAC address in the MAC address table, which is AC0A, which means that and this was actually here as well, which is this interface, which is the MAC address of this virtual router. So you can see that these devices will also use the MAC address of the virtual router. So that was all about HSRP. So thanks for watching.